Hello everyone, this is Aparna from TecLov. So in continuation to learning Python, today we will look at file operations in Python. We will look at the different modes available for file operations. We will look at how to open a file, read a file, write to a file, and more importantly close a file, and understand why it is important to close a file in Python. We will also briefly look at how to find what is the current working directory and change the working directory. In real world, a file is a collection of papers that are relevant to us or important to us. It's the same in computers. Files are used to save information or data when we talk about computers or programming. So if I show you my desktop, you will be able to see all the files that I have listed. Now I can open any one of the files, work on it, and close it. Even after I shut down my PC or computer, I will still be able to access this file. That is because a file is stored on a permanent memory in the computer system. This memory is not volatile, meaning if a program is running and I'm using that file in that program, and after I have closed that program, the file will still exist. So let's look at file operations in Python. Now before we begin, I want to find out what is my current working directory. In the sense, where is the system currently pointing? For that, I will install a package called OS in Python with the command import OS. And then I will type os.get current working directory. Currently, the system is pointing to this working directory. In the C drive, under username, users, there's a file folder called me. So let's look at it. Here in C drive, under users, there's a file folder called me. And these are all the files that are listed in this folder. So if I want to look at all the listed files in that folder, I will just have to type os.list dir, and this will give me the same list of files that you have seen before. But I have decided not to write any program into this folder. I would rather want my files or folders to be on the desktop. So how do we change the directory? To change the directory, the command is os.ch for change and dir for directory. Now I can't leave the parameter blank because I have to tell or what directory I want to be working in. So I can either type the full path. Here I'm just copying from here and saying I want to work in desktop. If you see in these list of files and folders, desktop is also one of the folder. So I want my directory to be pointed at that, and I will execute this command. When I execute this command, I can recheck what is the working directory with the command get current working directory. Now you see that the directory is indeed my desktop. So I can read and write files from my desktop. Now I want to look at all the files on my desktop. Again, I will say list dir, and that should give me a list of all the I have not mentioned the package of the command. So this should be as list dir, and now it should execute. So these are the files that are there on my desktop. Here, these are the files that are there on my desktop. The same list is reflected here. Now I want to open, say, TecLov.txt. How do I do that? Can I simply write open TecLov.txt? I can't. So I will assign it to a file object called myTextFile, and I will open the TecLov.txt file, and then I'll execute it. Now there are a couple of ways of reading this file. One way is to say print star my text file, and execute it. This shows the contents of the file. Let's open this file on my desktop and see whether it's the same as what is being shown here. I'll go here, open, and yes, it is the same content of the file that is being shown. Coming back to the Jupyter Notebook, another way of reading the file is using the read command. So for the sake of ease, I will execute this again and then say my text file dot read and execute it. This is another way of reading the same file. Here you are seeing the next line characters denoted by /n, and /t would mean a tab character. Know under which mode the file has been opened. I can do that by saying my text file, this being the file object in Python, followed by .mode. This gives me the mode in which a file has been opened when I execute it, R. So even though we have not defined any mode here, it reflects R when I ask for the mode. That's because R is the default mode. So even if you don't mention it, it still executes it in the read mode. Now that I have executed the file, executed this read file, and I'm looking at its contents, I want to find out where the pointer is right now. So the keyword for knowing the current position of the pointer is called tell. All I have to do is my file, my text file dot tell, and this gives me the current position where the pointer is in the current file, 869. So 868 would be the number of characters in this file, and after that 869 is the position of my pointer. Now say I want to read my file again. I will say my text file dot read. Can you tell me what the output will be if I execute this? The output is an empty space. That is because the pointer is at the end of the file, and when I re-execute the read command, there is nothing to read. That is why it is shown by a white space. So I want to take back the pointer to the initial position or say the 50th position. So all I have to use is a keyword called seek. I will write my text file .seek and give the position where I want to change, give the pointer's position where I want to take it. So when I execute this, it's taken that. Then if I read the file, if I re-execute this code offline to read the file, it will not start from the beginning of the file. It has taken the first line completely. It consists of 50 odd characters, and then it started from this full stop and then saying this is a text file. So you can set the offset and change the pointer's position with the help of seek. Again, to repeat myself, tell gives the position of the pointer, read reads the file. At the end of the file, if there is nothing to read, it will give an empty space, and seek changes the pointer's position. You have to give what position you want to take the pointer to as a parameter to seek. Now that I have read the file, I want to check if I have closed the file. To check that, I can simply type my file object. In this case, it's text, my text underscore file, my text file, followed by closed. Now this gives me a Boolean output. It can be either false or true. In my case, it is false because the system is saying that the file is still open. So to close the file, I will type my text file followed by .close and execute it. Now when I check whether it is closed or not, the result should be true, and it is indeed true. File is open, it is prone to unnecessary changes. So after we have finished our work with the file, ideally we should close it. So we can type this command, the file object's name followed by close, to close the file. Now closing is also important because it frees up the system's resources and also makes sure that we don't accidentally delete or modify the file. After I have closed the file, I want to see if I can still read it. When I execute this, it will immediately throw me an error saying that the file has been closed. Now I can close the file every time if I open one by stating .close to the file object, or I can do it implicitly with the keyword with. Let me show you an example. So if I want to open the same file and close it implicitly without stating close, all I have to write is with open TecLov.txt, the name of the file. I will mention a pseudonym. I want to open this as TL_1 and end it with a colon. Then I will say I also want to read this file, so I will say read_TL is storing the contents of TL_1. and I execute this. There is no output here. But let's check if the file is closed or open. We'll ask tl_1 dot closed and execute it. Without having to state to close the file explicitly, the file has been closed. Now, after it is closed, I want to read the file contents. Since I have assigned the contents of this file to read_tl, I can say print read_tl and execute it. This will get me the file's contents. So print read_tl will get me the file's contents. Now let's look at how to write to a file. To write to a file, I will use, say, wrt file. Again, this is a file object. I can give it any name. And I want to write the examples file. We have seen here, there's an example text. I want to use this file to write something. So I will first open it, saying example.txt, and now I will specify the mode as write. If I say just write, it will only allow me to write. But if I say write followed by a plus, it will allow me to write and read as well. So let me execute this file. Now I want to, let's see what is there in this file before I write anything. Let's go to my desktop, open the example file. There is nothing, it's an empty file. So going back, let me write to this file. I will say write underscore file dot write. Notice that I am writing the file by using the file object's name followed by write, and I am writing the content. Say I am learning Python. The next line I want to write as I am enrolled as a student with TecLov. So this is the content I want to write in the example file. Now, after executing this line, let me go ahead and close this. Now let's see if whatever we have written has been registered in the example text or not. And it is registered in the example text. We used the new line character. That's why the line I am enrolled as a student with TecLov has come in the next line. So instead of going and checking every time whether you have written or something, it's a good practice to reopen the file and read it. So let's reopen with open example .txt as read file, print read file dot read. And it does show whatever we have written has been written into the empty file example, and we have confirmed this going to the desktop as well as reading the file in Python. I can also read line by line of a file using the read line keyword. Let me show it in the coding. So say I want read line, open. Let's open the same file, example.txt. Then say read line followed by dot read line. This command reads line by line. If I execute it again, it'll show me the second line. If I execute it the third time, it'll show me an empty space because there is nothing after this line. So I'll go ahead and close this read line file, rd line dot close. Now that I have written something into the example.txt file, I want to add more. The way I can do it is by using the append mode. So I can write something like with open. I'll use the same file, example.txt, mode as append, and name it as append file. Append file dot write. In a new line, I would want to write Python is an easy language to learn. I'll execute the code. Now let me read the file again with open dot txt as read print rd underscore read. It's thrown me an error. That is because I made a mistake here. Instead of underscore, it's going to be a full stop. So I have appended a new line saying Python is an easy language to learn to the already existing two lines. by using the append mode. There is another way to create a file using the mode X, standing for exclusive. So in this mode, the file is only created if it is not already existing in the directory. So if I want to create a file, say with open, let's take the example of the earlier file we have used, TecLov.txt, and specify the mode as X as X_F file, followed by print X_file dot read. It should throw us an error because the file already exists. So unless and until it is a new file name that I want to create, it will throw me an error. But I can create a new file with a different file name using the mode X. So let me copy and paste this and say TecLov_2. And if I want to read it, let me say plus and then execute. It is returning an empty space because there is nothing to read. Let us go and check if TecLov_2 file has been created on my desktop, and here it is, and it's an empty file. So we have seen various modes to read a file, write to a file, and open a file, and more importantly, close a file. Now Python can read binary files apart from text files, and for that we use the mode B. Binary files are generally images or videos or some compressed files. I already have some video file here. Let's look at opening the file. You will not be able to understand or read that file in characters, but it will show us data in bytes. Some video file .mp4. I want to execute it in read binary. R for read and followed by B for binary as by file. And then I want by_file dot seek to. Then I can say to read the by file from 10. Then I want to print the binary file and tell me the position. And finally, I want to print the mode in which the file has been opened. So when I execute this, it's thrown me an error. So that's because I have made a mistake here. Instead of a full stop, a dot, I had given a comma, and it has given me this as the output. So binary files, or the B mode as an extension, is used for image files, video files, or compressed files. We have covered almost all the modes to read a file, write to a file, close a file, and we have also seen the exclusive mode as well as the binary mode of a file. All these were with text files, barring the binary file. Now if you see my desktop, there is an Excel file. I want to open this Excel file, but for opening an Excel file, I need to first install a wonderful package from Python called Pandas. So I will import Pandas. And then I can read an Excel file. You see TecLov.xls file is here. Let's see if we can read it. I will say my Excel file equals to pandas dot read dot underscore Excel. So read underscore Excel is the call function to read an Excel file using Pandas. We are specifying Pandas because this call function does not inherently exist in Python. We have imported the library or the package called Pandas. Let's give the parameter as TecLov.xlsx. And then I want to print the Excel file, my Excel file. When I execute it, it opens whatever is there in the Excel file. Let me open this. This is my Excel file data, and the same is reflected here. So with this we come to an end of file operations. Revising what we have gone through, we have looked at various modes of operation, how to open a file, read a file, write a file, and close a file. We've also read a binary file. Then we have looked at how to get the current working directory. Then we have also looked at how to find what all files or folders are there in that directory. And we have used change directory to change the file folder to a different directory. I hope you have understood this and enjoyed learning Python file operations. Hope to see you in the next video.